All right, good evening again. Our final talk for the night is going to be Rich Cassara with Hiding in the Shadows. Also, I hear that he is the best developer for POSHSEC.
Lies,
So
do not believe it.
give it up for Rich.
Thank you. So yes, like you said, I'm Rich Cassara. I go by RJ Cassara on Twitter and in my MISEC IRC channel frequently. So that's where you can find me at on the internets, because I'm not often at conventions, but this one is close to where I live, so I can come to this one. So this is Hiding in the Shadows. ShaDOS is a new PowerShell module that I'm working on, which I'm going to be introducing here. So a brief bio on myself. My daily job, I do mostly sysadmin DevOps work. In my spare time, I work on the POSHSEC project, which is a really amazing tool started by Matt Johnson over there, along with Will Steele, who is no longer with us. And then Ben 10 came along with his POSHSEC framework, which really amplified how awesome the tool is overall. I also, in my spare time at home, I like doing a lot of gardening and landscaping, which I like to think of as land hacking. Because instead of making computers do things that they weren't intended to do, I'm taking a crappy backyard and making it do new, awesome things that it wasn't originally intentioned to do. The other thing I do with most of my spare time is I train the next generation of hackers. I have the reverse engineer. He likes to take things apart to figure out how they work, and they frequently do not go back together again. I've got the physical penetration tester, who can climb and get into any space, no matter how much you think you can hide something. And then the newest member of the team is our social engineer, who just smiles at you and you will do whatever she wants. So now to get into the actual meat of the presentation, this is ShaDOS. So as I said, it's a PowerShell module, and it uses alternate data streams in Windows in order to hide data. And so what you can do is you can take some critical piece of data and secure it. And I don't know if that's too small, but I have a disclaimer that this code is entirely experimental and for research purposes. And if you try to actually secure anything important and lose it, I hold no responsibility for that. So for anyone who's not familiar, the alternate data streams in NTFS, it's a feature that was originally, Microsoft put it in for compatibility with Macintosh HFS file system, which has separate resource forks and data forks. So this allows, you can have a file, and then you can have a stream that's associated with that file. Now this is, and this can be accessed from command line with, you take your file name and you can put a colon, and then if you know the name of the stream and put it after that, you access that stream. And you can, so basically you can use this to attach files to your files. So currently, the way that these are used in current use, there's two places where we see it. Microsoft uses it themselves, and it can come up in malware a lot. So Microsoft uses it for internet zone info. So when you download something from the internet, it tracks that if you have the internet set as an untrusted zone, then it knows, okay, this exe came from an untrusted place, you can't run that. And if you want to run it, you need to go into the properties and uncheck a little box that says, I trust this, we can run it now. That's tracked by, and there's a stream attached to that that marks that. There's also the fave icons for your bookmarks in IE. Those are kept as a separate, as a stream on those links. And then additionally, a lot of the summary info for a file can be kept in a stream. And then on the malware side, we see lots of rootkits use alternate data streams because it hides, it makes the data really hard to find if you put something as an alternate data stream and it doesn't exist anywhere else on the system. So that got me to thinking about, well, if the bad guys are using this to hide data, why can't we on the blue teams use this to hide data so that it can't be exfiltrated? And that's kind of how this whole process was born. So it's written with PowerShell, and the reason I did that is because PowerShell is awesome. It's just a really PowerShell is just a really great tool environment that Microsoft's built. It's one of the best things they've done in years, and it makes administering Windows pretty much like administering a Linux system. They even map all the common Linux commands to Windows, to PowerShell commands. So you can jump between administering different environments and feel totally comfortable. So getting back to the module, ShaDOS, the way that I've designed it is that it creates a what I call a meta file. It contains meta info about the files that you're trying to hide. And it acts like a sort of miniature file system within NTFS. And that's why I've chosen to name it ShaDOS and write it that way. I'm calling out to DOS because it's putting a simple file system in there. And the ShaDOS because it's hidden in the shadows. And the files that you write to it, you can only access by using the functions within the module. So the meta file, which keeps track of all of this, it tracks all of the information that you put in, including you give each file a name, and then it randomizes a location for it, and it keeps that location. It randomizes a string, which is the name of the stream that it's attached to. It keeps track of last modification date and whether or not that file is password protected. That's an option within there. And the meta file itself can optionally be password protected, which I would highly recommend, because if it's not, then if someone broke into your machine and was trying to find this critical data, if they knew about the project, they could theoretically find the ShaDOS meta file, because that one's easier to find because it has a defined stream name. It keeps ShaDOS is the name of the stream for the meta file. So if they find that stream name on a file, then they know that that's the meta file, and if it's not encrypted, then they can read that and see what other files you've written and where they are. But if those are encrypted, they can also you can still minimize the damage, but if you encrypt the meta file, then it's even harder to get to. So where should you attach the files was a big question that came up while I was developing this. Because if you delete your host file, say you have a text file on your desktop and you put some streams on it, and then you decide you don't need that text file anymore and throw it out, you've now lost all those streams. So we need stable files in order to attach this. So the stable location that I thought of was using the system files. And incidentally, this is also how malware thinkers think when they are hiding their rootkits. They're typically found in the system files. So the pros for this are that there are tons of files there. Because I'm randomizing the location, it gives me a pretty large pool. There's roughly 2,000 files that I'm choosing from. And it's hard, because they're hidden in the system files, it's hard to delete those files from the system, because the OS tends to complain about that a lot. And then on the con side, it's difficult to do because like I said, the OS complains about deleting it. They protect the files pretty heavily. So during development, I had to figure out how I could get into the files to write this, which I'll get into in a minute. And also, there's a potential to damage your system. It's another disclaimer. I haven't fully tested this. Everything seems to work fine, but there could be a potential for damage when you're messing with system files. I'm not writing. Question? What's that? Oh, well, the thing is, if the base file changes, but the stream should still be the same. Because it's attached to the file name, I don't. Yes?
Well, the question is, if instead of like opening the file for
I'm not sure. It's possible. I haven't had a chance to test this yet. This is an early alpha research project, and I haven't gone through all of that yet. But it is an excellent question, and and that's why it's a tricky thing, and I'm not certain whether or not it works. Whether or not they would remain during an update. I've applied Windows updates and everything has remained in place, but I don't know if those particular DLLs were touched at that point. So at this point, what I've put into ShaDOS are three main functions. There's the get ShaDOS, write ShaDOS, and read ShaDOS. The get is going to read your meta file and list your files. This is like your ls or your dir command on a command line. It's going to grab your file names. Right now it just does file name and modification date. And I can adjust the code to pull out other things. I wrote there that whether or not they're password protected, but right now it doesn't do that. But it's trivial to add that in. And what it does is it first checks if there's a password protection on the meta file. If it is and that password protection is kept in another alternate data stream on the same file. So it has the meta file stream and then another stream called password. And if that password is set to 1, if password exists and is set to 1, then this knows that file's password protected, and it will prompt you for a password to decrypt your meta file first. If password doesn't exist, then it's just going to assume that that's a plain text, and it's going to read it out. The write ShaDOS, this is how you're going to hide your files within ShaDOS. So we take, it has a randomizing function, which is going to, it's going to list, take a random DLL file out of syswow64, and then it will create a random name to use as an ADS stream name, and then it's going to attach those together. And so you can set your data as a text string, or you can pipe in from you can do a get content and pipe that over to write ShaDOS, and it'll move that information in. You can also set a password. You can separately set a password on each of these files, so they are encrypted with their own passwords separate from the meta file encryption. The write ShaDOS function, I also put in the initialization code so that the first time you use this, it's going to say, I don't see a meta file. Do you want to create one at a specified location or randomize it? And if you can tell it to randomize where your meta file goes, or you can say put it on a specific file, and then and it keeps track of that in an environment variable. And then finally, the read ShaDOS function is going to take the parameter of the file name that you want to get back out. And so you say, I want to read this file that I've hidden, and it's going to take that content and write it back out. You can pipe it into a file, or you can have it output to your screen. And that is also going to check if the password's required. That is kept track of in the meta file, where it has a password bit in its string. And if password's required for that file, it'll prompt you for the password before decrypting. So the big question I want to get into now, I have some recorded demos which I hope will show up. They might be too small. I'm going to get to in a bit. But first, why am I doing this whole thing? So this was an idea I came up with to play around with, and I just wanted to follow through with it. There's too many times where you get an idea for something, and then you find out, oh, there's this other open source project that already does this and does it better than I could ever do it. Or, there's this product that does a much better job of this, and yeah, that costs a ton of money, and this is just costing me my time, but it's polished, it's nice, this is going to be ugly and terrible. But, I think it's important when you get a lot of times when you get an idea like this, you need to follow through and make sure, see if you can do it. Just make sure, you have this idea and you think it's going to work, and go ahead and follow through with it, because it helps you complete something. It gives a lot of practice, getting better at coding, figuring out things that you're doing wrong, and learning, pitfalls that you didn't expect that come up. When you tackle those, you learn a whole lot from going through with it, even if the end result is something that might not be the most impressive thing. It's something you did, and you can take a lot of pride in that. And you utilize that experience then in other ways. Like if there is another open source project that does the same thing, if you built your own version that's not quite as good, well, maybe you can contribute to the better one, because now you know a lot about how it should work and what it's doing, and you can find out things that are missing and say, hey, I kind of tackled that problem a little bit, maybe I can add to it, and just overall add to the community in that way. Continuing with why did I get the idea in the first place? First there was the idea of turning the alternate data streams on their head, where in general they're used for, when you hear about them in InfoSec, it's how there's malware attached to them. It's a bad thing, you got to look out for these. Well, if the malware guys are hiding their stuff with it, maybe we can hide our more important things. Because if a file is stored in an ADS, it's going to self-destruct as soon as it leaves an NTFS environment. So if someone, now they're on your machine, if someone got physical access to your machine and plugs in a USB drive, in general, those are going to be FAT32 formatted, and if they steal every file on your computer, they still won't get the info that you put in those ShaDOS files. Same thing with CD or DVD. Those aren't usually, they're not necessarily writing that to an NTFS formatted partition on there. And if someone comes in on a Linux box to attack your machine, if they are trying to exfiltrate your files over the network, they're not getting any of this information because they're not on the NTFS. So this badass hacker coming in with their Linux box, he's going to be shut down. So now I'm going to do a quick check if these demos are going to look halfway decent. It's pretty tiny. So up at the top here, I'll describe it for if you can't quite see it. I don't think I can make it any bigger, unfortunately. So what I've got here, this is the initialization. So this is the write ShaDOS function, and so what I'm calling here is I'm calling get content on a testdata.txt file that's on my desktop, and then I'm piping that into write ShaDOS, and I'm assigning it a file name, that's the parameter here, of testing1. And just to show, hold on, I've got the, where is that? So this is the file that I'm piping in, and it just says testing ShaDOS piping. So when I run this, there we go. All right, so I'm going to execute this command, and here it says the ShaDOS meta file is not defined. Enter desired location or type random. I typed in random, and then it tells me here the meta file is going to be located at this windows.device.wifi.dll. And then it takes a moment here to process before it comes up and asks me if I'm going to encrypt this. And it says yes, no, and it's recommended. I say yes, I type in a password, I confirm the password. If the confirmation fails, it won't let you do it. So, and then it goes through and it says it has successfully processed that file. So now, what happens, so I did that, and then I did this. Hang on. Then I ran my get ShaDOS function. And now this one, hold on, I can this. So I ran get ShaDOS, and this was before I implemented the code to decrypt. And this shows I ran get, and it just pulls the string from that ShaDOS file. Because I put encryption on it, it encrypts the file, and then it writes it as a base 64 string. So if you were to just undo this base 64 string, you would get gibberish because it's encrypted and then encoded. But then I went back in and added the handling for it. So now this is a demonstration where I type in get ShaDOS after I get ShaDOS, and it says metafiles password protected, enter password. I put in my password, and it comes back with testing 1 and the date that I wrote it. Then to check, I ran get ShaDOS again. I entered a wrong password, and it throws a big error at me because I need better error handling. And then finally, the read function. I go in here, and then I'm going to pull out that file that I put in. So here we do read ShaDOS, and I put in the parameter file name, testing 1, which is what I assigned it. Now it's asking me for my metafile password again. I put that in, and it comes back out with testing ShaDOS piping, which is what I wrote in the initial text file. Now I do it again, put in the bad password, and it fails as expected. So, and we went back too far, and we get to see Hacker Man again. Okay. So the future roadmap for things that I realized during the process that I definitely would want to add to this if I have time in the future. Deleting. Right now I'm just writing, reading, and listing what's there. If you wanted to delete something that you put in there, it's pretty easy to do. There's a PowerShell function, remove item. If you do a remove item on that file stream, it'll drop it. But I want to wrap that into a function that goes into the module. I also need to add collision checks. It's unlikely, like it's a non-zero chance that the randomizing will pick the same DLL and the same random file name to overwrite a file that you already put in. So that's something that would be really bad. So it needs to have a collision check on that. And I also need, as you saw, the error handling is not up to snuff, but it does catch them in some places, but there's other things that could be done much better. But those are the main things I see in the future roadmap. There also needs to be, as we've discussed through the questions, a ton more testing on whether or not Windows updates can wipe these things out. I'm really not certain at this point. I could do a test on it at some point, but split lots of time. It's hard to find time to do personal projects a lot, and we do the best we can. So, if there's any other questions, I'm happy to take them. Yes. Oh. There's none that I'm aware of. It might be tied to the OS file size limit, but I don't think there's anything on there. You should be able to pipe. I haven't fully tested it out, but the intention was that you could even take like an exe file, pipe the whole thing in, and hide it, which malware authors are already doing. So it is something that can be done.
I just wanted to make a comment. I appreciate you doing this because, like some of your other tools, I use these examples as PowerShell demos to like people that are not used to PowerShell. What you can do with it. But we're like, what can you do with PowerShell?
Right.
Yeah, you can create Exchange accounts, but
and
it just shows you can do some pretty elaborate things.
Right. And I forgot to mention, it's not currently up because I didn't get a chance to upload last night, and my code's on my virtual environment at home. But tonight I should be uploading all of this to GitHub. My GitHub is Cassara with a dash after it because of a mishap with a phone reset and the lost authentication code. So the Cassara account that I initially had on GitHub is inaccessible now. So when you have two-factor authentication, always have backup codes. Yep. Yep. I know that I haven't done it through my code, but I know that they do persist through NTFS over the network. People have done that, so it's possible.
We would need, then you, with your stuff, we would need the meta file.
Right. If you just moved a file, it could keep the stream on it, but that stream would be it would have a random stream name, and if you so if you didn't password protect the info, then someone could look at that file, see that there was a weird stream on it, and get that data from it. If it was password protected, they would have a garbled string attached to it that they wouldn't be able to decrypt without your password.
So what about doing, like, I'm thinking about writing a pull request for your thing here, but what about like a move function that would kind of take that string out of one meta file and could move it over to another one? Did you do that?
I think so.
Like a
Yeah.
migrate analysis?
It should be possible, in theory. Shadow? What was that?
You should be able to use standard DOS utilities to copy the
Yes.
data stream
Yeah.
from one file to another.
Right. You can copy it on the file system. I don't know about how it works copying over the network to another machine, but I think it should be possible also. Yeah.
Do you know if ultimate data streams get their own node or if they're like some weird UI structure kind of like
There's a lot of, I don't know all of the details of how they're implemented. It's hard to find a lot of concrete information on it. So I think that ends. Oh,
How many ASCII middle fingers have you been in data streams?
I have not put any in yet. Not yet. I could make that a new function. That would be a function that just puts it into the file.
Like, let's say Matt leaves his machine and walk up with some script that, let's say, just puts it in there and the data stream is not encrypted, so that maybe one day he's doing something on
Yep.
the system, he finds it just like a nice Easter egg.
Yeah. Or then you have another code that calls it to pull it out randomly. A logic bomb.
Pull request time.
Thanks, Rich.
Thank you.